Hey David, so I've been feeling a little understimulated lately, and I've been thinking, remember back when we were in college together and I took some programming classes so that I could understand you better, relate to you better when you were talking about all your nerd I actually did okay. I think I did all right, and I enjoyed it. I just didn't continue with it, and it stopped making sense. And I was thinking, with you as my teacher, maybe I could do better. So, how would you like to give me the Python?
Okay, Ren, if you want the Python, then the first thing you're going to need to do is download a program called PyCharm Community Edition. That's spelled Pycharm. It should be the top result on any web search, and it'll take you to the download page. There, the first thing you'll see, it's going to say PyCharm Professional. All you have to do is scroll to the bottom of the page. You'll see PyCharm Community Edition. Just click download, install that. That should be everything you need to do Python programming. All right, so when you first run PyCharm, it should look something like this. Click New Project, pick a location for your project, and this is also where you give your project a name. So Python Lesson 1, might as well. You don't have to deal with this. You're not going to be doing anything with Git for a little bit. I'm not even going to show it in this video. Go ahead and click Create a Welcome Script, though. And that will generate just a simple hello world program so that you can just click run and make sure that your PyCharm install is all correct. Everything on the left here, this is your project. These are all the files in your project. You don't have to worry about this folder, the .venv, that's short for virtual environment. There's a bunch of behind the scenes stuff that gets set up for you that you don't have to worry about. You can just collapse that. The only thing that's actually part of your project is this one file called main.py, and that's actually what's open here. This contains your welcome script. All you have to do is just click play, and it should say, "Hi PyCharm," right here in this little console that pops up to show you the output of the program. So we don't need that. Let's go ahead and maximize this. We can go ahead and just delete all this code, and we'll get into it. To get started with any programming, you need to be able to create variables. So let's create a variable called 3, and it's 1 plus 2, and that's it. So if we print that variable, we'll just run this program real quick, you'll see it prints the number 3. And you can also skip the variable. You can just print out a result. So 5 times 3, we'll hit run. You can see down here, we print 15 instead. But of course, you don't always want to print out a result. You want to do some useful work and then save it for later. All right, and if you do need to do any sort of math that's a bit more complicated than just what you can type out on your keyboard, there is, of course, like a math library that you can bring in. You do that by just saying import math, and that gets you access to a bunch of nice, useful things. So you can use it like so. We'll calculate a distance real quick. So you type in the name of your import, and then a dot, and then that'll gain you access to all of the things that are inside of that package. And then you just type in the name of the thing that you want. So I'm looking for square root. See here, there it is. So I can just hit enter, types out the rest of it for me. 3 squared plus 5 squared. This is how you do exponents in Python. You just type in your multiplication symbol twice, and then now that we have that calculation done and saved to a variable, we can print out the variable to see the result. And there we go. You can, of course, also do all of this with the variables. Yeah, hopefully that's pretty straightforward. I know if you have some experience with other languages, like in C and C++, for example, to create an integer like this, you have to say int. You have to declare the exact type of the thing that you're making. You can't just make a variable. I think it was in Visual Basic, you have to create a dimension, they call it. And in other scripting languages like JavaScript, you have to say var, short for variable, but Python doesn't have any of that. So we don't have to worry about it most of the time. There are ways for you to explicitly tell Python what type of thing you want to make when it matters, but generally you don't. Speaking of printing your results and your variables, There's a lot of different ways to print things in Python, and most all of the programs that I'll be showing in these courses are all just going to be console programs where you're going to want to print your results, and you're gonna want them to look nice. So generally, you're just going to type in print and your parentheses, and then the thing that you want to print out. You can actually ignore this little helper bubble for now, because there's a bunch of extra optional things, like you can add separators. We'll get into that kind of stuff later when it really matters. Just for now, you're just going to type in print and then the thing that you want to print, if it exists. It is also possible, though, to just go ahead and just print a string of text. This is some text. So then when we run this program, that just shows how easy printing is in Python. However, sometimes you want to do something a little bit more complicated. So I'm going to go ahead and create two variables real quick. Name, and then a greeting. Curly braces to denote a placeholder. And then we'll go ahead and I'll show you. If you just print the greeting, it's not going to do what you'd hope. It's just going to print that text exactly as you typed it, curly braces and all. But if you then, after the word greeting, do a dot, you can see that this is also some sort of container of tools. It's not just holding the text that we typed here. It has a bunch of capabilities to it. And they're all listed here, and the one we want is called format. So then format itself, you have to put parentheses after it. It's asking for an input, and it shows you it wants a string of text, a literal string. So we're going to hand it name. So let's add a little space. So we're using print. Print is expecting some sort of input. In there, we're using greeting and the format ability that it has, and it's expecting a string of text to be handed into it. So when we run it, it now says, "Hello, Rob Forrest, how are you?" And this allows you to swap things out anytime you want. You can reuse the same message over and over again with different inputs, and it'll change. Now, formatting text is actually so common that Python has a nice little shorthand for it so that you don't have to type all of this. This gets cumbersome. And it's especially convenient when you're going to be handing in the same variable over and over again, and you know that you're not going to be changing that anytime soon. So we can get rid of all this. And we can even get rid of this variable here. Let's just take what we want to type. We'll get rid of the variable. Reduce this all down to 2 lines of code. So what we're going to do is we're going to wrap this in quote marks. And then in front of that, we're just going to put an F. You'll see that the placeholders suddenly highlight. So the F immediately in front of your opening quote tells Python that this is a formatting string. It's not just a regular string of text. It's formatting text. And it's expecting the variable right here. Python's design philosophy is compactness and simplicity. So I can hit run and we get the same output as we had before. So there we are. All right, so let's get to the interesting stuff. We're here to program, so we want the programs to be interactive and we want them to make decisions. Otherwise, they're kind of useless, and why are we doing all this? All right, so we'll take that greeting example again. And we're going to basically do the opposite of print. We're going to do an input. Then we will print out the result as a formatted string. And so now we have a nice little 2-line program. When we run it, we just get this blank console here. Doesn't seem like it's doing anything, but it's still on line 1. It's waiting for us to type something. There we go. And then it just prints. So input also can take in some data that it can work with. So we'll have it print out this message, "Who are you?" followed by an empty space. And when we run the program again, now it actually makes a little bit more sense why it's not doing anything. Getting on to other statements, we'll have the if statement. And it takes in an input. The input for the if statement is going to be any other valid Python statement that boils down to a simple declaration of true or false. Like 2 is less than 5. This is a statement. In this case, it's true. Now, what's different about if is a special keyword that the language understands, and it's going to change how your entire program flows. So after if, we're going to put a colon. And you'll notice that my cursor is not against the edge. Python has automatically added 4 spaces for me. This is how Python groups your code. If the previous line is true, all the code right here is going to get run, which in this case I will just say, I'll just print 2. Why not? All right. Now, I can backspace all these, and then I can say else. Else doesn't take in any inputs. We're just going to put the colon, and again, we're now automatically tabbed in 4 spaces. And I'm just going to print 5. Lots of C-like languages, they use curly braces to group your code. So an if would actually look something like this. You'd say if, blah, 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 and then you would just have these curly braces at the end. And then anything you type inside of the curly braces is all one big block of code that's all going to get run together if and only if this statement ends up being true. Otherwise, it'll skip the block. Python does exactly that same thing. It just does it without the braces. So in order to group your code into a big block that is skippable, it all has to line up. Just going to go ahead and hit run, and you'll see it prints out 2. It's always going to print 2 with the way that I formed this if here. In fact, that's actually why the editor is trying to be helpful right now. So if I hover over this line, it says, this code is unreachable. That's fine. So we will say, just for demonstration's sake, 6 is less than 5, which is false. So when I hit run, it should print 5. And it does. It prints 5. All right, so what can you type here? Well, there are a lot of options. So let's say we've got a couple of variables. I'm highly imaginative, so we're just going to go with A and B, and we'll say A and then something and B. So like I did before, we've got less than is an option to see if A is smaller than B. There's also greater than. But what if I want to check to see if they are the same? I can't do this. You can see we get a red underline immediately. This is an error. Unexpected expression syntax. Just means that Python did not understand what you were trying to do here, because a single equal sign already has a meaning in this language as it's being used up here. So we are making the variable A be equal to 3. We're making that happen. We, right down here though, we want to check if that was the case. So we have to hit equal twice. This is the symbol. That's how you check if two things are the same. But there's also other, helpful ones. Like, what if we want to see that A is less than or equal? Like, we're fine with it being equal, but we're checking to see if it's less than. Then you can combine them, can form what looks a little bit like an arrow here, where you're saying A is less than or equal to B. There's also greater than or equal, and then there's also not equal. And there's a bajillion of these. This is probably a good time to talk about references. Highly recommend, even if you're an expert, to go to w3schools.com, as the references here are incredibly minimalistic and straightforward. This entire website is both a tutorial and a reference. And then scrolling down a little bit on the sidebar, they've also got more detailed references down at the bottom. Getting back to PyCharm, let's put everything we've covered already and a couple small extras all together to make our first real program. So first, I want to show you how to write comments. So if you just type in a pound sign or a hash sign, whatever you want to call it, if you just type that, then anything you type after it is ignored by Python. This is for human readable text. This is how you leave comments in your code. You can also put these at the end of code lines too. So you can have, real, actual code here, and then a pound, and then anything after that pound, again, it's just ignored by Python. All right, so I'm going to comment out what we're going to do here, and then we're going to build a program around the comments. What this program is going to be is a secret number guesser. It's going to use everything we've seen so far, plus one extra thing, not counting the comments, of course. So we're going to do an import, because we need this library of tools called random. This is the name of the library, or I guess Python calls them packages. So we need the random package. There's a nice little thing here, though. I don't want to be typing random every single time I use something from this package. So I'm going to add in as R. That way, all I have to do is type in just the letter R. It's going to be much nicer. So random number generators are great. First thing we want to do is use the random package, and we want to find a tool called seed, which is right here. This lets us make the program predictable. We're going to give it just an arbitrary number. As long as we always give it the same number, it'll do all of its mixing and blending of that number in a consistent and predictable way so that we'll always get the exact same result. And we're going to create a variable called secret. And it's going to hold the result of a function called randint. And this function takes two inputs. You can hover over functions and you'll often get documentation for them. So return a random integer in the range of a to b inclusive, which is exactly what we want. So I want a random number between 1 and 10, and I want to include 1 and 10. So to test out the program, we can uncomment this code and we can print the secret. So now we see with this particular seed, the very first random integer that we're going to get is going to be the number 7. So knowing that, we can test the program. I'll comment out that code again though. So down here, I'm going to make a variable. It's going to be the user's guess, and it's going to be an input. And what do we want to tell the user? We're just going to ask the user, what's your guess? And then a little empty space so that they're not typing butted up right against the question mark. Now, this does present a problem. What I didn't explain earlier, and it's really important now, is the output of this function. So we give it the string of text as input. It's then asking the user to type something, and then it's going to give us an output that we're storing in this variable. That output is a string of text, but we're going to be needing this to be a number. So to do that, Python has a number of built-in convenience functions for reading strings of text and then interpreting them as some kind of a number or some other piece of data, and then translating it into that data and handing it back to us. So I'm going to take this variable user guess. I'm going to make it equal to the result of this function. All right, so this is a conversion function for making integers out of strings of text. So it contains a string of text here. It gets converted. The result then replaces that string of text with a number. We're just storing it in the same box it came from. And now that it's a number, we can actually treat it like a number and use it in an if statement correctly. So if the user guess exactly matches the secret, we can do a task here, which is just going to be to print congrats, basically. All right. Now here's the new thing I want to show you. There's if, then there's the else statement. Then there's also an else if statement, but unlike other languages where you could actually type out the words else if, in Python you type in elif for short. I'm going to make this one interesting. We're going to check to see if the user typed in something close to the secret, just off by 1. So it's going to be user guess. We're going to check to see if it is equal to the secret plus 1, or, and this is another special keyword, we could also put and. In this case, we need it to be or. And you always have to really spell things out for the computer. So everything on the left of the or is completely independent of whatever you're doing on the right. So I can't say this like a natural human sentence. I can't say if the user guess is equal to the secret plus 1 or minus 1. I have to say if the guess is equal to the secret plus 1, or if the guess is equal to the secret minus 1. Little verbose, but kind of inescapable. Computers are not people. So we'll just print another message here. Lastly, else. Nice thing about else is any of the previous checks fail, then else is just a nice catch-all. And you can have, you'll always have one if at the start of a chain of these. You'll always have one else. You can have as many of these else ifs as you want, checking for anything you wish. So here in our little catch-all, we're just going to print nope. And that's the entire program. So let's go ahead and run it. What's your guess? My guess is, which of these do we want to hit? We know it's going to be 7. So let's go and just check all 3 of these in order. So we want to say got it. So we'll type in a 7. It says got it. Now the program's over. Program automatically shuts off when it's done. So we have to run it again. So let's do a 6. No, but very close. And we should get the same thing with an 8. 8. No, but very close. All right, let's run the program one last time. And then we'll pick something. We'll pick something else. 1 says nope. And now here's a good chance for us to really mess with things. Let's do 700. That's way off. It's going to say nope. We're not actually doing anything other than this conversion to sanitize what the user types in. So we can actually type in anything we want. I'll just mash my keyboard, hit enter. We break the program. But even though it lacks some serious error checking, that is a full program with everything that we've covered today. All right, so I actually have a few challenges to offer. I've got 4 of them specifically, and they should all have solutions that are about this big. You can actually make a very simple calculator, and I mean simple. Takes in a couple of numbers, spits out an output. You could do an age verification program. You could do temperature conversions. You can even do a rock, paper, scissors game. So let's backspace all this. All right, so here's how the challenges are going to work, if you're interested. First is the simple calculator. So how it's going to work is you're going to ask the user specifically for 2 numbers. Next, going to ask for an operator, specifically just the 4 basic ones on the keyboard. And you're going to ask for the operator just by asking the user to actually type one of these 4 symbols. That's the easiest way to do it. And then you just print the result. You should be able to do that in somewhere between 10 to 20 lines of code. All right. The next challenge is an age checker program. So the whole point to this program is to ask the user their age, then print if they are old enough for something. So I actually have a whole list here. So if they are younger than 13, just tell them you aren't old enough to do anything. Then if they are greater than or equal to 14, it's going to be driver's license. Oh, sorry. For age 14, it'll be a learner's permit. Age 16 or older, it'll be the driver's license. Okay, and then if it's going to be 18, they're old enough to vote. If it's 21, it'll be drink alcohol. And 25, they get a price break on insurance. You don't have to do the whole list. All right, so the next challenge is a temperature conversion, and the formula is listed here on Math is Fun. So for this program, you just ask the user if they want to convert from Celsius to Fahrenheit or from Fahrenheit to Celsius. Just ask them to type in either a C or an F. You can actually set up the program to be case insensitive too, so you can ask them basically for a C or an F or an F. After you've asked them which conversion they want to do, ask for a temperature, and then just print the result. So the last challenge is a simple rock, paper, scissors game. Like all of the other ones, specifically just asking them to type in the letter R, P, or S for the given throw they want to do. And then using the random library, you have to decide on a throw. So I think this one can be an interesting one to think about, considering that the random library has a ton of tools for giving you a random number, not a random letter. But I don't know. I haven't actually made use of Python random. Maybe it does have a tool for a random letter. I don't know. My solution used random numbers, so surprised me. I do want to add though, like all of the previous challenges and like the example program that we wrote together on screen here, just make the program run once and spit out a result. Don't bother trying to figure out how to make it like a best 2 out of 3 or anything like that. We'll be able to write those kinds of programs later.